Hello everyone, today we are going to be talking about Lesson Master 69B. This was a homework assignment. I'm going to go over 5 questions from this homework assignment. Even if I don't go over the ones that you necessarily had questions on, make sure you're following along because a lot of the ones I'm going to go over have some that are similar to it, and I'll try and point those out kind of as we go as well. So on the front side here, I'm going to go down to the bottom here. I'm going to do both 17 and 19. So 17 and 19, we are asked to rewrite the expression into a plus bi form, or in other words, we're just asked to simplify it. And now this is really my division problem because I have a complex number on the top and a complex number on the bottom. I'm going to turn my paper sideways here, and I'm going to actually copy this problem over here into the margin so that I have a little bit of space to do this. So this is number 17, and I'm going to copy it down here. I'm starting with a 4 plus I on the top, and on bottom I have a 6 minus I. Okay. The way we deal with our division problem here is again that we multiply, and I'm going to multiply by the conjugate of the bottom. And the reason we do that is multiplying by that conjugate is going to get rid of the i's, and I'll be left with just a regular real number there. But because I multiply by that on the bottom, I also have to multiply that on top. When I do that, I now create for myself 2 entire FOILing problems. So I'm multiplying 2 binomials together. So the first one on top, I'm going to multiply the 4 times the 6, which gives me a 24. I'll do a 4 times an I, which gives me a 4i. I'll do the I times a 6, which gives me 6i, and I times I gives me a positive I squared. And we'll deal with the simplifying here in just a minute. I'm going to multiply on the bottom first though. So 6 times 6 gives me 36. 6 times I is 6i. Negative I times 6 is negative 6i, and negative I times I is a negative I squared. Alright, last thing I need to do here is simplify both top and bottom. So on top, I'm just going to bring the 24 over. Then I have the 4i and the 6i. It gives me a 10i, those being added there. And then an I squared really just becomes a negative 1. Okay, so my answer there is the negative 1. Then on the bottom, I have the 36 just comes over. My positive 6i and negative 6i actually cancel here, and that needs to happen. If it doesn't, I either multiplied by the wrong thing or I multiplied incorrectly as I went through. And then a negative I squared. Well, I squared is a negative 1, so it's a negative 1, which really means I'm adding 1 there. If I combine just those regular numbers together, those real numbers, I have 24 and a negative 1 gives me 23, and then plus the 10i, and 36 and 1 just gives me 37. Okay, the last step of all of these is to just split those apart. So 23 plus 10i over 37 and 37. Sorry, I shouldn't have put my fraction bar in the middle there. Just get rid of that in a second. Okay, just separate those apart. Sorry, you can't even see what I was doing. Looks like that. Okay, so that is my final answer because none of these will reduce. 37 is actually a prime number, so there's no way for me to break that down any further. So for 17, turn my paper back the right way here. My final answer is 23 over 37 plus 10i over 37. Okay. Then I'm going to also do number 19. So again, I'm going to turn my paper sideways here so I have a little bit of room to do this. But I'm starting with a 12i all divided by 10 plus 3i. Now this one is still a division problem, but it's slightly different because on top all I have is the 12i. I don't have that normal a plus bi form. I don't have the number in front of the 12i. That doesn't really change anything because my issue is with the I in the bottom. And so I still need to multiply by the conjugate. The way I multiply by that conjugate is I take the 10, I switch the sign on the I, which makes it the 10 minus 3i, and I still need to multiply by that same thing on top. Really, the only difference now is that instead of foiling across the top, all I'm going to really do is distribute. So I'm going to distribute the 12i times the 10, which gives me 120i. Then I'll distribute that 12i to the negative 3i as well, which gives me a negative 36i squared. Okay. Then I'll go down to the bottom. This is a regular FOIL, so 10 times 10 is 100. 10 times negative 3i is negative 30i. 10 3i is positive 30i, and negative 3i times 3i is negative 9 squared. And I'll take my I now. On top, my I squared is going to make my 36 positive, so I'm going to have 36 plus 120i. Right, and on bottom, my 100 will definitely come through. My i's will cancel, and my negative 9 becomes a positive 9. So that's going to give me 109 on the bottom. So 36 over 109, I'm going to split this apart right now as well. Gives you 120i over 109. Hey, again, I can't reduce those because my 109s are prime. There's no way to simplify that. So my final answer here again is going to be 36 over 109 plus 120i over 109. Okay, now I just did 2 problems on this front page, but there are some other ones here that are similar. 16 is really the same as 17, and 18 is more or less the same as 19. You don't have the I on 18, but you're really still just distributing it on the top there as well. Okay, 11 also works the same way as both of these problems. You need to multiply by that conjugate of 3i, which is a negative 3i. Next, I am going to move to the back here. There are 3 problems on the back here that I want to do. We just tackled a couple division problems. I also thought we should look at some addition, subtraction, and multiplication. So, first one I'm going to look at is number 20. This is the only subtraction one on this page. For subtraction, we're going to actually change this to adding a negative. So I'm going to take my negative and distribute it through. By doing that, I change my sign in between my 2 numbers to a plus. And now I have the 12 plus 3i on the front. That one doesn't change. But my second complex number, all of the signs change. So the negative makes the 2 a negative, so it's a negative 2. And the positive 6i will become a negative 6i as well. Then I can combine my like terms. So I have 12i and negative 2 gives me 10. And 3i and negative 6i is negative 3. So my answer there is going to be a 10 minus 3i. All right. Moving on to number 23. This is your adding problem, which is really the second half of what we just did here. All I'm doing is combining like terms. So I'm going to combine the 4 and the 10, gives us 14. Combine your i's, which is negative 3 and a positive 2, gives you a negative 1i, or just negative I. The 1 there is optional. If you want it, you can have it. If not, don't worry about it. All right, and final problem I'm going to tackle is number 28. Now, number 28 is a multiplication problem, although it looks now like I'm squaring it. Okay, now we know that squaring it means that I take that piece that's in parentheses and I write it out 2 times. Okay, now I have to make sure I do that. I cannot just take the squared and apply it to both the 4 and the I because of the minus that's in the middle there. Same thing on 29, I can't do it because of the plus that is there. So that squared really just means I'm multiplying it by itself. So this is now just a regular multiplication problem. Now, when I chose to do one of these versus one of the other multiplications, because at this point this is the same as 26 and 27, as well as 21 and 22 that are up top here. So this problem is really the same as those at this point. You just have that first step of splitting it apart. From here, I'm going to FOIL these together. So I'm going to take the 4 and multiply it by the 4, which gives me a 16. I'll take the 4 and multiply it by the I, which gives me negative 4i. Negative I times 4 is negative 4i. And negative I times negative I is a positive I squared. Finally, I'll simplify those. Negative 4i and negative 4i is negative 8i. Bring down the 16 on the front. A positive I squared is really like a negative 1, so there's a minus 1 there. Combine my 16 and my negative 1. My final answer here is going to be 15 minus 8i. And there's my answer. Okay, so hopefully those answered most of your questions. If not, do your best to look at the answer key and see if you can find what I did and get those answers. My answer key will be available for you to look at. I am also about to show it to you as well here. So if you need to, pause the video so you can look at these. I'm going to quickly kind of put them under the document camera here. So starting back on the front, number 1 is your definition of a complex number, which is simply a number composed of a real part and an imaginary part in that form, a plus bi. Okay. 2 through 7 here, all the way down to number 9, where your real parts, as well as a couple conjugates in there. So I'll give you a chance to look at those. Again, if you need to, pause the video. Bottom portion here, you're writing all of these as a plus bi. Some of the simplifying is a little bit strange, so if help with these, you ask. On the back here are all of your simplifying ones again. Quick note on the back here, make sure everything is in a plus bi form. So always put the regular real number out first, and then the number that goes with the I goes second.